Have you ever thought about how even like adding a simple tablet mount to a cockpit could actually end up like impacting an aircraft's safety margins?
Huh, that's interesting.
Yeah. So today we're going to dive deep into the world of aircraft weight and balance and like what happens after you make modifications or repairs. You with me?
Absolutely.
Okay, cool. It's a pretty crucial topic.
It really is. And you know what's really fascinating?
What's that?
Sometimes our intuition tells us that only big changes matter, right?
Right.
But even small changes, like you said, even adding a tablet mount, can actually shift the aircraft's center of gravity.
Yeah.
And that can affect how it performs.
Totally.
It really highlights the incredible detail that goes into aviation safety.
Yeah, absolutely. And that's actually what we're going to be looking at today. The core of our discussion is the FAA's Weight and Balance Handbook, which is basically like the Bible for mechanics and repair pros, you know?
Right.
It tells them how to like account for every single change that's made to an aircraft. And for our listeners out there, getting a grasp on these principles, it's like a window into those super rigorous standards of aviation safety.
Definitely.
And those specific procedures that are designed to keep, planes operating safely in the air.
Yeah.
So whether you're a total aviation geek or just like fascinated by complex systems and how they work, this deep dive, it's for you.
Yeah, and it's interesting when you think about it because these procedures aren't just some arbitrary hoops that people have to jump through.
Right.
They're really fundamental to how we ensure that aircraft fly predictably and safely.
Yeah.
So our goal today is to try to distill the most essential information from this handbook and specifically focus on how we document and then calculate weight and balance changes after we modify an aircraft.
Exactly.
Yeah.
And because this is the official source, like the thing that the people doing the work actually use, this gives us like the most legit, authoritative view of the entire process, right?
Yeah.
So where do we even begin with all this? It seems like a lot.
Well, I think the first thing to really highlight is that the handbook makes it crystal clear that it's the responsibility of FAA-certified mechanics or repairmen
Okay.
to accurately document any weight changes
Uh-huh.
that result from any alterations or repairs.
Got it.
And this isn't just like a quick note, right?
Right.
They have to meticulously record this stuff
Yeah.
in both the aircraft's maintenance records, which makes sense, and the pilot's operating handbook or the aircraft flight manual.
Right.
We call that the POAFM.
POAFM. Got it.
Yeah.
Makes total sense. The pilot needs to like know what's going on with the plane, right?
Exactly.
It's not just whether the thing works, but how its weight and its placement has changed the balance of the whole aircraft, right?
Absolutely.
Which leads us to this thing called the weight and balance record, which you've got an example of, right?
Yeah, exactly. Imagine this. The weight and balance record is like the aircraft's continuous story.
Okay.
It's a detailed history of every single change that's ever been made to it, affecting its weight and center of gravity.
So every time something happens to the plane, it's in this record.
It gets recorded, yeah. And they're really specific about it.
Okay.
There are these columns,
Okay.
and you've got the date of each change, a specific item number, a detailed description of what was changed, whether it was added or removed.
Oh, wow.
Then you've got how much weight changed, like in pounds. And then there's this thing called the arm.
The arm, okay.
Yeah. And essentially that's just the horizontal distance from a fixed reference point on the plane.
Okay.
And we call that the datum.
The datum, got it.
And then finally we have the moment, which we get by multiplying the weight by the arm.
Okay.
And a lot of times they'll divide that by 1,000 to make the numbers easier to work with.
So every single modification, even if it's like a new antenna or a new seat, it goes into this document.
All of it gets recorded, yeah.
That's incredible.
It is pretty amazing.
Now, you also mentioned this thing about minor and major alterations. What's the difference?
Yeah. So the FAA, they consider adding or removing equipment that's already on something called a comprehensive equipment list to be a minor alteration.
Right.
And actually, the handbook's got a good example of that list.
Okay.
So say you've got a radio that's on the list, and you replace it with another radio that's also on the list.
Okay.
That's a minor alteration.
Okay.
And so the paperwork for that is a little bit less intense.
Oh.
You just have to make a record in maintenance logs
Uh-huh.
and update the weight and balance info in the POAAFM.
Okay.
And that's because those items, they've already been looked at
Okay.
by the manufacturer and the FAA.
Oh, okay.
They've assessed the impact on weight and balance, and they've decided it's all good.
Got it.
So swapping them out, generally it's within those pre-approved limits.
Okay, so like if I swap out a light bulb with the exact same kind of light bulb, that's not a big deal.
Exactly. We're really talking about changes that measurably affect the plane's weight and where that center of gravity is.
Okay.
Now, major alterations or repairs, those are a whole different ballgame.
Okay, what makes those so different?
These are like the big changes
Yep.
to the plane's structure or the engine or the major systems.
Got it.
And, the handbook is really clear that light sport category aircraft, they can't undergo major repairs or alterations.
Oh, wow.
But for other planes, these major changes, they need FAA-approved engineering data.
Oh, wow.
They need a sign-off by a mechanic who holds an inspection authorization.
An IA.
That's right, an IA, or by someone authorized at an FAA-approved repair station.
Yeah.
And you're going to need a formal repair station record,
Uh-huh.
and sometimes even an FAA Form 337,
Okay.
which is basically just a document that's specifically for major repairs and alterations.
Got it.
And of course, any major change, it needs a revision to the aircraft's weight and balance record with a date on it.
Okay. So something like installing a whole different engine or
Right.
changing the wings of the plane, that's definitely major, right?
Yeah, that would be a major change. And it requires all that extra review and documentation.
Got it. Okay. Now let's go back to this comprehensive equipment list for a second. What's the point of this?
Right?
And how is it different from the list that's specific to my plane?
Yeah, that's a really good question. The comprehensive list, like the one we have here for the Cessna 182S, it's essentially a master list
Okay.
of all the equipment that could be installed on that model.
Okay.
But it's not tied to any one specific plane.
Oh,
Your individual airplane will have its own list.
okay.
And you'll find that in the back of your POH.
Got it.
And that details exactly what was installed when your aircraft was made.
Okay.
So think of the comprehensive list as like the menu of all the possible options.
Okay.
And then your POH's list is your specific order
All right.
from that menu.
I got it. So the comprehensive list is like the options catalog, and my POH is what's actually in my plane.
Exactly.
Okay, that makes sense. And I see all these codes and numbers. Like, what are all these dashes and letters next to the equipment?
Yeah. So those codes, they're all based on the Air Transport Association's specification, ATA Specification 100.
Okay.
And that gives us a standardized way to categorize all the different aircraft systems and components.
Got it.
The first two digits, those tell you which system the part belongs to.
Okay.
So like Chapter 11, that's placards. Chapter 21, that's air conditioning.
Makes sense.
And then those suffix letters, those are important.
Okay.
Say ITA R, that means the item is required by the FAA, like for certification standards.
Oh, okay.
AAS, that's standard equipment for that model.
Okay.
AAO means it's optional, but it replaces a standard or required part.
Okay.
And AA means it's optional, and it's added on top of the standard or required equipment.
Got it. What about those little asterisks next to some of the line?
Oh, yeah, good catch. Those mean that it's a complete assembly.
Oh, okay.
So they've installed a whole assembly, and then the parts that make up that assembly are listed right below it.
That's really organized. So after any of these changes, it seems like this weight and balance revision record is super important.
It is. That's like the official documentation for any changes to the weight and balance.
Oh, okay.
And the handbook stresses that you've got to keep it with all the other important records.
Got it.
So every time you modify something that affects weight and balance, you make a new record.
Okay.
And you got to include the date, the plane's make and model, and serial number. And then the person who made the changes has to sign it
Okay.
and put down their certificate number and type.
I see. And it also says if there are old calculations that aren't valid anymore, you got to note that too, right?
Right. That's all about having a super clear history.
Yeah.
So when you make new changes and do new calculations, the old ones aren't good anymore, right?
Right.
So this makes sure everyone knows exactly what's up to date and what's not.
Makes sense.
No confusion. Everyone's on the same page.
Got it.
You can see in the example how they document the removal and installation of stuff and how they get to a new empty weight and a new useful load.
Okay, so we've documented the changes. Now for the math part.
Well,
Pat.
now for the fun part.
Okay. The handbook talks about calculating the center of gravity, the CG.
Right.
After you make a change, it uses weight, arm, and moment.
Yep.
Can you walk us through that?
Yeah, absolutely. Basically, the CG, it's the point where the whole aircraft would balance perfectly if you could just suspend it in the air.
Okay.
And anytime you add or remove weight, that balance point shifts.
Makes sense.
So to calculate the new CG, you got to make a table,
Okay.
just like the examples,
Uh-huh.
and you list everything that changed.
Got it.
What was there before, what's there now.
Okay.
For each of those things, you got to know the weight and the arm.
The arm, which is the distance from the datum.
That's right. And then you get the moment, which is just weight multiplied by arm.
Okay.
Do that for all the changes. Add up the new weights to get the total new weight, and then add up the new moments to get the total new moment. And then to get the new CG, you just divide the total new moment by the total new weight.
Okay, so like in the example, they start with a plane that weighs a certain amount, has a specific arm, and that gives you a moment.
Yep.
And then if they take off a piece of equipment, they note its weight and arm, and that gives a negative moment.
Exactly.
If they add new equipment, same thing, but a positive moment.
That's right.
Then they add up all the weight changes, all the moment changes, and that gives the new total weight and the new total moment.
Uh-huh.
Divide that new moment by the new weight, and boom, new center of gravity.
Exactly.
That seems pretty straightforward.
It's a very systematic approach.
Yeah, definitely. Now, the handbook also mentions this other way of doing it, using weight and moment indexes.
Right.
What's the deal with that?
Yeah, so instead of using those big moment numbers, use this thing called the moment index, which is just the moment divided by a constant, usually 100 or 1,000, just to make the number smaller and easier to handle. Okay.
So you start with the aircraft's weight and its moment index.
Yeah, okay.
Then for anything you remove, you subtract its weight and its moment index.
Got it.
And for anything you install, you add those.
Okay.
That gives you the new total weight and moment index.
Mm-hmm.
Then to find the actual CG, you convert that moment index back to a moment by multiplying it by the same constant you used earlier.
Okay.
And then you just divide that total moment by the total weight.
Same as the first method.
Exactly the same.
So it's just a way to use smaller numbers.
Yeah, it's just a matter of preference or how the data is already set up for that plane.
Okay.
But both methods get you the same result.
That's good. And once you've got the CG, you know, how far it is from the datum in inches.
Yeah.
Sometimes it's more helpful to show that as a percentage of the mean aerodynamic chord.
The MAC.
Right, the MAC. And the handbook shows how to do that, right?
It does.
So the MAC, it's like the average width of the wing.
Yeah, you can think of it that way. And the LEMAC is the leading edge of that average.
Exactly.
And the formula they give is CG in percentage, MAC, equals the CG in inches of the LEMAC divided by the MAC times 100.
That's right.
So if we say the loaded CG is 36.4 inches from the datum, and the LEMAC is at 25.98 inches,
Okay.
then the CG is 36.4 minus 25.98, so 10.42 inches behind the LEMAC.
Okay.
If the NAC is 58 inches, then we do 10.42 divided by 58 times 100, which gives us about 17.9% MAC.
That's right.
Now, why do we even bother with this percentage thing?
Good question. So you can think of the MAC like a representative average wing chord, right?
Okay.
And when you express the CG as a percentage of the MAC, it gives pilots and engineers a standardized way to understand where that center of lift is going to be
Okay.
relative to the center of gravity, no matter what the size of the plane or the shape of the wings is.
Okay.
And that helps ensure that the plane handles predictably, even when you've got different loads.
So it doesn't matter if it's a big plane or a small plane, we can still compare them using this percentage.
Exactly. Expressing the CG as a percentage of MAC lets pilots and engineers quickly check if the plane's balance is within those limits.
Okay.
And those limits, they're usually defined in terms of that percentage.
Got it. It's like a common language.
Exactly, a common language for the longitudinal center of gravity.
Yeah.
That doesn't depend on how big the plane actually is.
That makes sense. Now, the handbook talks about the empty weight CG range, or EWCG range.
Right.
And some aircraft have this listed in their type certificate data sheet.
They're TCDS.
For the TCDS.
Yeah.
What does it mean if they have a range listed there?
So if they have a specific EWCG range in their TCDS, it means that the design of the plane and where they put the heavy stuff,
Right.
the fuel tanks and the seats and the baggage compartments,
Uh-huh.
it means they put it all in a way that changes in fuel or passengers won't mess up the balance too much.
Okay.
So if you do all your changes and your new EWCG is still within that range,
Yeah.
you might not even have to do those adverse load CG checks that we talked about earlier.
Well, that sounds nice.
It is convenient.
But the handbook also says that for a lot of planes, the TCDS just says none for the EWCG range. What does that mean?
Yeah, you're right. Most planes don't have that built-in balance thing.
Okay.
So when the TCDS says none for the EWCG range, it means that every time you change the weight and balance, you got to do those checks.
Okay.
You got to make sure that even in the worst case scenarios,
Yeah.
the center of gravity stays where it's supposed to.
Got it. So those adverse load CG checks are super important for most planes.
Mm.
What exactly are they checking?
Basically, they're trying to simulate the most extreme forward and aft loading situations.
Okay.
Like the worst case scenarios you might actually encounter when you're flying.
Oh, wow.
And the goal is to be absolutely sure that even in those crazy situations,
Yeah.
the center of gravity stays within the safe limits for that plane.
Okay.
That's super important for keeping the plane stable and in control during flight.
Yeah, that makes sense. Let's start with the forward adverse load CG check. What do they look at for that?
So for that check, they imagine the plane is empty,
Okay.
just the pilot's in the seat,
Okay.
and they've got the minimum fuel to fly.
Okay.
The handbook usually says that minimum fuel is however much you need to fly for half an hour at full power,
Okay.
and they base that on the engine's METO horsepower.
METO horsepower.
Except takeoff.
Okay.
And in the example, they use 115 pounds of fuel.
Okay.
The idea is to put as much weight as you can,
Yeah.
as far forward as you can,
Okay.
while still having enough fuel to actually fly for a bit.
And in the example, even with just the pilot and that little fuel, the CG is already too far back, right?
Yeah, it is. It's behind the limit.
Oh, wow. So what does that mean?
It means there might be a problem with the balance in that situation.
Okay.
It's like even in this really light configuration, the center of gravity is already further back than it should be.
Oh, wow.
So they might need to make some adjustments,
Okay.
like moving some equipment around or adding ballast weight.
Got it. Now let's look at the aft adverse load CG check. What's different there?
So in this one, it's still the empty plane with the pilot.
Okay.
But now the fuel tanks are full.
Okay.
There are passengers in the back seats
Yeah.
and baggage loaded in the compartments,
Okay.
as much as they're allowed to carry.
Got it.
The idea here is to load the plane as far back as they're allowed.
Okay.
And in the example, with all that stuff loaded,
Yeah.
the CG is just a bit ahead of the limit.
Oh, okay.
So in that specific case, it's still within the safe zone.
Got it. So even with the plane loaded up, the CG is good.
Exactly.
Yeah.
It shows that even when the plane is loaded to the max,
Yeah.
the center of gravity stays within those limits.
That's really important.
It is. These checks are super crucial
Yeah.
because they make sure the plane is going to be stable and controllable no matter how much weight you've got on board.
That makes total sense. What if, after all those calculations and checks, the CG is still outside the limits?
Then they got to use ballast.
Ballast. Okay.
That's basically extra weight
Okay.
that they put in specific spots
Right.
to get that center of gravity back where it should be.
Got it.
And there are two types, temporary and permanent.
Okay.
Temporary ballast, that's like lead bars or bags of sand.
Okay.
They use that for specific flights,
Mm-hmm.
and it's got to be secured and labeled.
Labeled how?
They got to put a placard on it
Oh, okay.
saying that if you remove it, you got to recheck the weight and balance.
Got it. What about permanent ballast?
Permanent ballast, those are lead blocks, usually painted red,
All right.
and they say permanent ballast, do not remove.
Oh, wow.
And they're attached to the plane structure.
So they're really there to stay.
Yeah.
And they have a formula to figure out how much ballast you need, right?
Yeah, they do. It's ballast weight equals the plane's empty weight times how far the CG is out of limits.
Okay.
All divided by the distance between where you're putting the ballast and where you want the CG to be.
Okay.
They've got a good example. It's a plane that weighs 1,876 pounds, and its empty weight CG is too far forward.
Okay.
They want to add ballast at a specific point on the fuselage.
Yeah.
And using the formula, they figure out they need about 7.7 pounds of ballast.
Wow.
And once they put that in and label it,
Yeah.
the CG is back in the safe zone.
That's amazing. Such a specific calculation for something that seems so simple.
It really is. It shows how precise they gotta be with this stuff.
Absolutely.
Yeah.
And finally, the handbook shows an example of a baggage compartment placard. What are those for?
Oh yeah, those are important. They tell the pilot how much weight they can put in each compartment,
Okay.
so they don't accidentally load the plane in a way that messes up the CG.
So they're basically like weight limits for the baggage.
Exactly. They help keep the CG within those limits.
So we covered a lot today.
We have.
We talked about how important it is to keep track of every weight and balance change,
Yeah,
whether it's a small change or a big one,
absolutely.
and the difference between minor and major changes.
And all the paperwork.
Right. All the paperwork.
Yeah.
We also talked about how to calculate the new center of gravity.
Using those two methods.
Right. The weight, arm, and moment method.
Yeah,
And the weight and moment indexes method.
that's right.
And we talked about those crucial adverse load CG checks
Super important.
to make sure the plane's safe in all kinds of situations.
Absolutely.
And then we talked about ballast.
Temporary and permanent.
Yeah, that extra weight that helps balance things out.
Exactly.
It's really amazing how much detail goes into this stuff.
It is. And, you know, even if you're not a mechanic, or a pilot,
Yeah.
understanding these procedures,
Yeah.
it really gives you a new appreciation for aviation safety.
Absolutely.
All these layers they put in place to keep things safe.
Yeah.
It's really impressive.
Totally agree. It makes you think about all the little things that matter in complex systems, right?
It does.
So here's a final thought for our listeners.
Okay.
Given all this precision that goes into managing weight and balance in a plane,
Yeah.
what other little things in other high-stakes environments might have huge consequences? It's a reminder that those small details,
Yeah.
they can make all the difference
Absolutely.
for safety and success.